Section 7-3, Part 2. Can you find the rate of change from a table by finding the change in the inputs and the change in the outputs? Remember, rate of change is the change of your outputs, which are your Y's, over your change of the inputs, which are your X's. Rate of change, remember, is rise over run. Change of your Y's over change of your X's. Remember, your Y's are your outputs and your X are your inputs. Okay? So what I want us to look at is a table, and let's see if this table represents a linear function. Well, what we want to look on the left side. What did we have to add to 1 to get to 2? You had to add 1. So from 1, if you take 1 plus 1, you get 2. You can also add 2 plus 1 and get 3. You can add 3 plus 1 and get 4. You can add 4 plus 1 and get 5. So you see every time on the left side of your input, you are adding 1 each time to get the next number. Let's see what's being done to the outputs. You see they are increasing. So if they're increasing, we must add a number. Just like on the left, they were increasing, so we added a number. Now, are we adding a constant number every time? 5 plus what's going to give me 8? Well, it's 5 plus 3. 8 plus what's going to give me 11? It's 8 plus 3. So 5 plus 3 was 8. 8 plus 3 was 11. 11 plus 3 is 14. And 14 plus 3 is 17. Yes, you see here that this table does represent a linear function because the change is constant. It was 1 all the way down. If it's not 1 all the way down, it is not a linear function. This side added 3 each time. It's got to be the same. If you add 3 here, it's got to be a 3 all the way down in order to have a linear function. So your rate of change is the change in the outputs. Well, your change of your outputs was 3. Divided by the change in the inputs. Well, your change in every input was 1. And 3 divided by 1 equals to 3. So yes, this table does represent a linear function. So next, let's look at the next 2 tables. Since the rate of change is constant and each input has only 1 output, the table does represent a linear function. That's the one we've been talking about. Yes, it did represent a linear function. Now let's look at these 2 tables. Identify the relation defined by each table representing a linear function. Does the relation defined by each table represent a linear function? So let's begin looking at each one of these. Let's look at the input. What is the change? I see that it is increasing. All right, from 0 to 1, I had to add 1. 1 plus 1, 2. 2 plus 1, 3. 3 plus 1, 4. So right now, my inputs were constant. Let's see if my outputs are also constant. 2 plus 2 gives you 4. 4 plus 2 does not give me 7. 4 plus 3 gives me 7. 3 plus what number gives me 8? That's 1. 8 plus what number gives me 10? That's 2. So 2 plus 2 gives you 4. 4 plus 3 gives you 7. 7 plus 1 gives you 8. And 8 plus 2 gives you 10. Is my output constant? No. Therefore, this is not a linear function. The left side, which is the inputs, they all must be constant, plus the right side, which is all of the outputs, they must be constant. So the rate of change from the first pair to the second pair was not the same. These are not the same, therefore this is not a linear function. A is not a linear function. So let's see about B. Looking at B's values, is this a linear function? All right, so looking at B. All right, from 0 to 3, I see I'm increasing by 3. 3 plus 3 gives me 6. 6 plus 3 gives me 9. And 9 plus 3 gives me 12. So I see that my input is constant. Now the question is my output constant? Because I have to have both the input and the output to be constant, all the way down. So I see that it's increasing. 0 plus 1 gives me 1. 1 plus 1 does not give me 3. 1 plus 2 gives me 3, so it's not constant. 3 plus 3 gives me 6, and 6 plus 4 gives me 10. So again, this is not a linear function because both the left side and the right side have to be the same all the way down in order for it to be a linear function. The rate of change from the first pair of numbers to the second pair of numbers was 1/3. The rate of change from the second pair of numbers to the third pair of numbers was 2/3. So 1/3 that I would get from the output over the input of the first point to the second point is not the same as 2/3, which comes from the second point to the third point, putting 2/3. These are not the same. And when they're not the same, you do not have a linear function. So all these numbers have to be the same change, and all these numbers have to be the same change to be a linear pair, or a linear function. And my outputs were not constant, therefore this is not a linear function.